Hello all, good morning and welcome to the class. Today we'll get started creating EKS cluster with the Terraform code. We have already seen creating an EC2 instance from here, right? So we'll create an EKS cluster with our Terraform code today. And for this, we will be using some modules for Terraform. Let us search for some modules. Modules of Terraform, modules from Terraform. Let us go ahead with the modules to the official repository. And yeah, like we browse for providers till now, we shall use some existing modules. First one is VPC module. See, we can create EKS with our default VPC also, but let us create our own VPC, our own cluster, right? So when you go for the EKS module, here there were some examples available on the GitHub. If you see here, source code available. Okay, again, some examples of how to create a VPC, like any other features you need. Okay, here is the example of providing the address, name, CIDR block, and ASIS. See, always the best practice to create a VPC with public and private subnets. Private subnets to hold the Kubernetes workloads, to run the Kubernetes workloads, and public subnets to expose the cluster, to expose the endpoint, the load balancers, right? So these are the important features. And enable the NAT gateway, enable VPN gateway, and some tags if you want. Okay, so we'll use all this code to create a VPC first. Then we'll spin up a Terraform. See, some examples code is here available. Okay, like whatever you want to deal with, you have a lot of examples here. So let us start writing our code with using this VPC. I'm going to create a file called vpc.tf, VPC for EKS or whatever, some name. Okay, and also yes, obviously we need the provider for it. Provider, AWS, okay, some provider, and then the region. Okay, some region. Let's say we are going to create in South one. Let it be, okay. Here also we can create, and then now some initialize variables and all variables, passing the variables will do everything. First, let's call the module. Module. Here you may give any name to your module. Okay, I'm just giving the name as VPC. This name can be any name of your choice. Here, call the module. Call the module. Right, this is the source name, CIDR blocks. We can have all of this. Let me add these three. Okay, so source some version. If you don't mention the version, it will use the latest version, or else you could use the version. Let me put some version which I am using is 3.14. Right, and some name like my VPC and the CIDR block. Okay, CIDR block we are hard coding for now. We'll later pass them as a values. And then ASIS, like availability zones. In which availability zone you want? I want to pick up this availability zone from the AWS console. So we have something called data sources, right, to pick up these availability zones. If you are not sure, just check here for, search here for, search here for availability zones. Availability, yeah, see, availability zone. Let's search one more availability zones. Yeah, ASIS. See a list of availability zones, names or IDs in that particular region. It will be returned as a string. Okay, list of values in a square brackets. So I just want that to return some value. Yeah, see data, like we are using data for region, I would like to use data for ASIS. Let us see, we may just see some examples. See outputs, ASIS can be outputs. Yeah, see here, this is how you can pass the variables, right? So Similarly, so is the ASIS. Let me just use some data source here. Data, AWS availability zones, availability zones, availability zones. Okay, and I'm just giving the name as available. Okay, so yeah, that's all. That should return the availability zone. So here now, how do I refer a data source? If you remember, we have used for AMS data dot the name AWS availability zones dot available, right? Dot names that should return dot names that should return all the names of the availability zones. Then we have to define the private subnets. Private subnets. I would like to use some variables, so just let it be. Similarly, public subnets. Okay, and that's all. And then yeah, enable the NAT gateway and enable the DNS host names. NAT gateway is to allow the internet traffic. We can allow NAT gateway and all the subnets can be routed through single NAT way. Right? That's all. And yeah, to identify this particular VPC by our EKS cluster, we could add some tags for both subnets and private subnets. I mean, public and private subnets. See here. Tag. Okay, this is the tag I'm using. My app EKS cluster. It's a shared. Subnets also. I'm adding a same label. What is this label? See, whenever we spin up EKS cluster, it will be using something called Cloud Controller Manager. Cloud Controller Manager will spin up the EKS cluster and it need to identify which subnets it can use, which private subnets, which public subnets it can use for the cluster. So it will identify using this label. And yes, elastic load balancer. Okay, allowing public elastic load balancer for public subnets, internal load balancer for private subnets. That's all. That should create VPC with all the custom configurations. Just let us do a plan command. Before plan, we should first enable it, like Terraform init. It will initialize the new modules, everything. By the way, I should do one more thing. First, let us do, before running it, AWS configure. Okay, I have got the new account, right? So let me create some security credentials. Go to security credentials. Let us create a new security credential. Access key, secret key, already something is there. Let me just create one. Root user access are not recommended. It's okay. Create the access key. Download the CSV. Okay, done. So those credentials I should be using here, and I would be checking my EKS cluster on which region. US West 2, I believe, right? US West 2 is Oregon. Is it US West 2? Yes. Oregon. Okay, let us put some text here. Let me get the key, okay? Downloads key. stopping the screen share for a while. Okay, so I have given those credentials. Now let us do Terraform plan first. Terraform plan. By the way, we have used some variables, right? We have to pass those values. Maybe I want to use the souls as a variable, side block and everything. So let us also use those variables. Let us define them in a separate file, variables.tf. Or else let me just define here itself. Instead of this side block, I would like to say variable VPC side block. Right, then variable private subnet side block. And one more variable for public subnet. For public subnet. Public subnet. Now assign the values. I'm removing this var.vpc side block. And then here var.private subnet side block. And here var.public subnet side block, right? So everything is good. Yeah, we need to pass these three variables from terraforms.tfvars. Just let me create terraform.tfvars. Okay, and let us assign all these values. See, depending on the region, okay, if your region has three availabilities, or generally will have three, so three AZs will be there. So for each AZ, there should be three private subnets, three public subnets, right? This is how it should be. For each AZ, there will be one private subnet, one public subnet. Suppose you have one region, okay, we are using US West 2. It will have three AZs. Three AZs means one public subnet, one private subnet for each AZ. So 3 into 2, 6 AZs. So accordingly, I have given here the network ranges. Okay, now let us do apply. var.private subnet side block. Terraform.tfvars. var.private subnet side blocks. Okay, I have given here blocks. What did I use here? Okay, let me say blocks. Okay, because it was different, it was asking me for the value. Subnet blocks. Let it be. Okay, now plan. Okay, 20 resources will be created if you just scroll down. right? VPC, NAT gateways, everything, right? You can see all of these values. It will create all of these values, and our VPC will be created, which is compatible for EKS. Now let's create the cluster. For that, we shall use another module. This is VPC module. So let us search for modules. Search for EKS module. Yeah, if you see Terraform module to create an EKS cluster and associated resources. So again, how to use the module, here it is. Okay, module EKS you can call it. And there were examples, everything available here. Yes. Okay. So VPC, subnet IDs, you can pass all of them. Self-managed node groups means you have to manage your own worker nodes. You have to create the worker nodes. You have to take care of a cluster, everything are there. Okay, I mean, you have to take care of installing kubelet, Docker, everything. If you use managed node groups, this is the best option. It will create EC2 instance, I mean, worker nodes which are from optimized EKS, right, AMI, so that it will have all the supported components needed for the cluster. Okay, so let us go for it, and yeah, let's create the cluster. Let us create one more file called eks.tf. Okay, so here again, module EKS and the address from where you want to pull up, and let me write here all the resources. Yeah, you can get it from Terraform document. Okay, version of the module, some cluster name, cluster version, subnet IDs. Say subnet IDs are being from another module. So how do you call that, right? So with the name of the module, see, my app VPC, I have given this name. Let me just add it here, the same, or else you may change it there. You have to call the same name. Okay, my VPC.private subnets, my VPC.VPC ID, because in that same VPC we need a cluster, not in any random VPC. Okay, some tags, and it's EKS managed node group. You can give some name to your node group. I have given name, minimum size is 1, maximum is 3, desired is 2. So that a node group will be created with actually 2 nodes. Clear with this code, everyone? Please go through it and ask me. It was like everything is almost self-explanatory here. So this will create one node group. Node group name is dev. You can have any number of node groups as such. Is this clear? The code clear for everyone? Can you run the code? First, let us do Terraform apply. I mean Terraform plan. Something gone wrong, it's giving error. The module, yeah, see, because I changed the module name, VPC name, okay, it is saying it's not installed. So whenever you use a new module, first do Terraform in it. Okay, now do Terraform plan. Okay, so 50 components will be created, which will take some time, but let's create it with auto approve. It should start creating the cluster. Meanwhile, it creates a cluster. Okay, once cluster is created, we will deploy from Jenkins server, right? So let us get our Jenkins ready. Okay, it should be creating the cluster. Meanwhile, let us start our Jenkins server. I don't have a Jenkins server ready. It's a new instance. Meanwhile, I'll quickly spin up the instance for Jenkins. Okay. Meanwhile, it is creating everything. So let me do one thing. Launch instance. Okay. Let the name be Jenkins server. It is Amazon Linux 2 t2.micro. Key pair login. Create a key pair. Create a new key pair. Which is of the PEM format, or it can be of PPK. First, let it be PEM. Later on, we can convert. Let it be AWS key. Create a key pair. Okay, it's downloaded. Security group. Allow all traffic. I want to add a rule. Let us edit. SSH and allow all traffic. There is an option to add rule. Okay. Allow all traffic. Launch instance. Yeah, meanwhile it was creating. And we have this PEM file, we need to convert this, right? Let us keep this key as well. I'm having this key into the SSH keys. Now let us use the quotation. Trying to download quotation. Okay, yeah, got it. Okay, so now put this file SSH keys, not this one. The one I have is this one, the one which is generated now. Now save the private key file. Yes. In the same folder is fine. Yes. Okay, done. Meanwhile, see the cluster is still creating. We can continue our work. And now I think I can connect this from Putty. Let us put this accept EC2 user. Sudo su hyphen. Fine. Now let us install Jenkins. Just give me 1 second. Okay, now quickly install Jenkins. Java should be installed, right? Java is not there. Let me install Java. By the way, it was asking for Java 11. Okay, let it be. Okay, I'm installing Java 8. Meanwhile, yes, cluster still on the way. 6 minutes. It took 6 minutes. It's still creating. Meanwhile, we can install Jenkins. Alternative configs Java. Okay, I just want this path to set Java environment variable till 64. This is the one I need. Now go to HC profile, export. Export the variables. Export Java home. Okay. Oh. Then export path variable as well. It should be $Java home, then path. Okay, source, let's say profile. Now go Java home. We already did this, so I'm not explaining this part. We have already done this. Now go to Jenkins download. Okay, so here it is. Copy. Okay, and then download the keys. Okay, install Jenkins. So that should help us install Jenkins. Confirm it. Okay, cluster is still on the way. Meanwhile, we can check here. Okay, here is where Oregon region we are creating the cluster. Yes, see, cluster is active. It was creating. Here you can see all the information, resources, compute. Okay, we have created one node group with two instances were not yet ready. The cluster is still spinning up. Okay. Meanwhile, yes, Jenkins is ready. Let us start Jenkins systemctl start Jenkins. Systemctl start Jenkins. What is the problem? Systemctl start Jenkins. Okay. Let us check the status. Okay, failed to start Jenkins continuous integrate. Failed to start. I believe it was looking for Java 11. Let me try this. This is the command to install. It was saying use this command in Amazon Linux too. Okay, confirm. Okay, now let us try to start again. Let's say restart. We'll do systemctl stop Jenkins and start it. What's the problem? Status failed to start. Jenkins.subcenter failed state. Jenkins.service failed. Failed to start. Status on. Alternatives config Java. Sorry. So this is also another Java we have. Let me just use this Java as a default. I'll also change the path, but just let me try. It was working. When you change it, the default Java means I need to use Java 11 for the new Jenkins. So let it start. Meanwhile, yes, cluster is ready, and it took almost 8 minutes plus 2 more minutes, almost 10 minutes. So cluster is ready. So you can check the cluster this way. Just go to the cluster. Okay, refresh it. You should see the nodes. Nodes are nothing but your instances, EC2 instances. No nodes. It was just loading. Just wait. Let's wait. Meanwhile, come to overview. See the server endpoint, certificate authority, CA for connecting to the cluster. Okay, all of them were created. And yes, 2 node cluster is ready. This is the node group name. And where is this node? Again, an EC2 instance. We are just going to that EC2 instance. See, AWS console, you can go to click this instance ID. You will go to EC2 console. See, EC2 management console in the same Oregon region. See, 2 instances might have been ready. Do you see that they belong to dev group t2.micro? Okay. And in which VPC they were? Let's go to VPC as well. Yes. Here is the VPC. Go to VPC management console. This is the VPC we have created for our cluster, my VPC. Okay. And this VPC might have got 6 subnets. You can check here. These are all the ones. Let us filter with my VPC. My VPC. Right, 1, 2, 3, 4, 5, 6. Do you see that? Total 6. 1, 2, 3 public and 3 private. Like I said, every AZ has got 1 public subnet and 1 private subnet. Right? That is the requirement for a EKS cluster. See, you can also see the nodes, the default pods running, everything here on the UI. And we have given a label, right? Some label as a dev group. Okay, you can see all of that here. Okay, not only that, because I have created a cluster, yeah, service started. Meanwhile, I'll show you some more. So because I have created cluster from here, obviously I can connect get nodes. I can connect from my laptop because I have created cluster from here with the Terraform. Earlier we have created manually, right, using EKS Okay, you can run the command AWS EKS update kubeconfig. Okay, there is some command to update your config. Give me a second, I'll show you the command. Okay, that is the command, but what is the cluster name? Yeah, I think it was correct. Added. Okay, added this context to kubeconfig. So yes, now you can connect. kubectl get nodes. Okay, perfect. We have already seen this, how to deploy load balancer service, everything, but now we'll do it through Jenkins. So done. But now my task is to connect via Jenkins server. So service started, I believe. Check the status. Okay, it was good. So it needs Java 11. Now let us exit from the browser to create our job. So this is the Jenkins IP. 8080 is a default port. Okay, you have to unlock it initially. Go to the server again. Okay, get this. And install the plugins. And on the Jenkins server, we need to connect to our EKS cluster. How do we connect? Anyone? Do you remember? We have already done that when we created cluster with EKS ETL. I have shown you how to connect. How to connect? Have we already done this connecting from Jenkins? I mean, connecting Terraform with Jenkins, already done this? Okay. Meanwhile, let me open our address book code. Yeah, here is the address book. We need to include Terraform stage, right? So earlier we have done this with EKS cluster, right? I mean deployment on EKS cluster. It could be deployment on EKS cluster, or else like whether you deploy it onto EKS cluster or whether you deploy it, call the code, whatever code, you need to include a call to Terraform, right? So we'll do that. Just let me remove all of this. Rather than modifying it, I'll just put the entire code. What we are going to do. See, cluster is done. And yeah. Actually, executing on a Kubernetes cluster from Jenkins is done, right? From Jenkins, we know how to run it on Kubernetes cluster. Now we need a Terraform stage included. So all of this remains as usual. See, let's say I'm deploying on EC2 instance. Whether you did this stage could be on a Kubernetes cluster or EC2 instance. This is the stage we need. Calling the Terraform code. Okay, providing access key, secret key, and then run Terraform in it and Terraform apply. That's all. And once it applies this, it may create EKS cluster or it may create EC2 instance, right? That EC2 instance public IP will be using for deployment. This is the catch here. Okay, so cluster part is done. We want to see running Terraform code via Jenkins. So let it finish.